In this lesson, we're going to talk about rational exponents and property of exponents. So here's an exponent or a power. So we consider the big number here the base of the number, and m is the exponent or the power. So if I see something like this, the 3 is the base, and the 5 is the power, or the exponent. And then all this means is, this is how many times we want to multiply the base by itself. So in this case, we're going to multiply 3 times itself 5 times. 5. That's what 3 to the 5th means. It means 3 times 3, 3 times 3, 5 times. And then you can multiply it all together and you get 243. Same thing works here. If I was doing this one, right? My base is x, that's the base. And this is my exponent, or power. So this means multiply x to the 4th means multiply x by itself 4 times. Okay, now that we know the basis, let's move on to a few of the properties. So the first property is a zero power property. That's anything to the power of 0 is equal to 1, except 0. And that is because I always like to think of anything to the 0 power as a number over itself. So it makes it 1. Right? So like if I give you 6 to the 0, that's just 1. Oh, over here, x to the 0, that's just 1. Right? Anything to the 0 power except for 0, that's undefined. For the same idea, you can't divide by 0, right? If 0 to 0 be 0 over 0, and you can't divide by 0. But everything else, it's just 1. So that's the first property, the zero power property. Anything to 0 power except for 0 is 1. The product of powers. To multiply powers with the base, you add the exponents. Coefficients are multiplied together. So all they're saying is like here, right? I'm going to multiply 2 to the 3rd times 2 to the 2nd times 2 to the 1st. All we have to do is add the exponents. So this rule is x to the m times x to the n is equal to x to the m plus n. So all we have to do is add all these exponents together. So 3 plus 2 plus 1, that gives me 2 to the 6. And if you look at this, right, that's the same thing as saying 2 times 2 times 2, 2 times 2, and 2, and we have 6 2's. So 2 to the 6. So that's the shortcut of doing this, right? If you're multiplying two things and they have the same base, you just add the exponent. So 2 plus 5 is x to the 7. Down here, right, same idea. We're going to keep the numbers and the exponents separate. So the numbers were multiplied together. So the numbers 3 times 2 and -1. Almost forgot the -1. That is -6. And then we got to do the variables. So we have x5. Remember, if there's not a power, it's a 1. So 5 plus 1 is x to the 6. Right? You're kind of telling yourself, how many variables do I have here? I have 5 plus another 1. I have 6 total variables. And then the numbers you just multiply. So same thing will happen here. Right? We're going to multiply all the numbers together. So I get 4 times -3 times -2. That's -12 times -2 is a positive 24. And then for the variables, we just do each one separately. So x squared, we got x. So we have a total of 3 x's, right? I had 2 here, I had another 1 there. And then my y's, I have 1 plus 5 plus 4. Right, that's the way we're going to do it. 1 plus 5 plus 4. So I have 10 y's total. Just like that. Next, the power of a product property. So all this is saying in this case is, if you have two things in parentheses to a power, oops, let's put a power, a random power, k, that goes to both of them. So that exponent goes to both things in the parentheses. That's what's going on here. So like the example here, this is a common example people get wrong all the time, right? 2x to the 3rd, I guess so many people give me 2x to the 3rd as the answer. No, that 3 goes to both of them. So it's 2 to the 3rd, x to the 3rd. 2 to the 3rd, 2 times 2 times 2, that'll give me 8, x to the 3rd. Over here, right, same concept, that 4 is going to go to everything. So 3 to the 4th, x to the 4th, y to the 4th. That's 3 times 3 times 3 times 3. So 9 times 9, 81, x to the 4th, y to the 4th. Over here, same concept, right? That 2 is going to go to every single one. So that's -3 squared. In parentheses, we'll talk about. Then we have x squared, y squared, z squared. Now, remember that -3 is going to power of 2. So I put in parentheses because when you square a negative, when you square anything, it should make it positive. Because right, you're doing -3 times -3. That's a positive 9. Two negatives make a positive. So anytime you do an even power, it should be positive. And there's my answer. The power of a power property. That's when you have a power and you bring it to a power. So AB to the power of K. All you do is multiply this times that. So it'd be ABK, like that. You multiply the power, you multiply the two exponents, right? So when we multiply and they have the same base, and in this case we would add them. You just add all the tops, but you make that a power to a power, like these, and then we're gonna multiply them. And let's show you why. So this first one here, right? So the rule says all we're gonna do is multiply these top two. So it'll be 3 to the 2 times 3, which is 3 to the 6. If you want to know why that happens, right? It's the same thing as 3 squared, and there's 3 of them. Right? That's what it's saying. 3 squared to the third power. So we're gonna multiply 3 squared 3 times. And look how many, and all we have to do here is add the tops, and you get 3 to the 6. So it's the same concept. Right? You can either add x to the 4th 3 times, and then add them all up, and you get x to the 12th. Or you can just multiply. That's why we multiply. So we don't have to add so many things together. So you get that. So that's the basic rule here. So in this case, right, same idea, that 2 is going to go with every single one. So -5 squared, x squared squared, y cubed squared, z squared. Right, z doesn't have like a power itself, so it's like that. -5 squared is 25. X squared squared is x to the 4th. Y cubed squared, right, so when we multiply those two, we get y to the 6th, and then we get z squared. So that's a power to a power. So power you multiply. A negative power, one of my favorite ones. So all that says, look what it says there, is you have a negative power that flips. So it flips the base. You get 1 over a to the n, like that. It works even if you have it on the bottom. If you have 1 over a to the n, or I should put a to negative n, that will flip to the top. Right, so a negative power flips it, flips the base upside down. You might wonder why that happens. Well, let's look at 5 cubed. That is 125. And if I want to divide that by 5, on this side you get 5 squared, which is 25. You divide by 5 again, and we'll get 5 to the 1st, which is 5. So you can see when you divide by 5, all you're doing is like losing the power on the exponent. So now we're just multiplying. Instead of multiplying 5 by itself 3 times, we're multiplying by itself 2 times. And then we're multiplying by itself 1 time. And then we get 5 to the 0. Well, divide by 5. That is just 1, right? 5 divided by 5 is 1. 18 to the 0 power is 1. And we divide by 5 one more time. You get 1 over 5, which is the same thing as, right? We're going to follow the pattern here. Every time we divide by 5, we're subtracting 1. So 5 to the -1. And you keep on going. 5 to the -2 would be divide by 5 again. 1 over 25. Or 1 over 5 squared. Right? That's it. There's 1 over 5 squared. So you can see how like it works. So negative power just flips it. That's all it does. So it flips the base. So if I was doing this one here, that's a negative power. So I'm going to flip the base. So that becomes 1 over 2 to the 3rd. Right? Sitting over here. It just flips the base. So 1 over -x to the 4th. Right? Going over here. Oh, it is flipped already. It's already a fraction, I should say. But that still flips it. So it flips the base. We're going to flip all this upside down. So that becomes 3 squared. Right, so 3 moves to the top. Well, honestly, what I should do is this. Let's distribute this first. So I get 1 to -2 and 3 to -2. That's going to flip up. That's going to flip down. So now you get 3 squared over 1 squared, which is the same thing as just 3 squared, which is the same thing as 9. So same thing we've done here, right? Flip that up, flip that down. 3 squared over 2 to the 4th. Or if I want the actual numbers, 9 over 16. All right, that's just 2 times 2 times 2 times 2, which is 8 times 2, which is 16. One thing I do want to mention is that when you have negative exponents, you don't want to end with negative exponents. They need to become positive. So if you see, right, I didn't just leave it 2 to -3 or 1/3 to -2. You have to flip it. You want to become positive exponents. So you don't ever want to end with negative exponents. You always want to into positive exponents. Okay, let's go on to the next one. Quotient of powers property. This goes hand in hand with the power powers, the product powers property, right? Where we had two things with the same base and we multiply them, then we just add the powers or the exponents. So it follows the reason that if you're dividing two things with the same base, that we subtract them. Now the way we subtract it, top minus bottom, very important. The top one minus the bottom one. So the numerator minus the denominator. So in this case, let's say we have this one. So let's show what's going on first, I guess. So we have 3 5s on top. 1, 2, 3, 4, 5, all being multiplied. All over 3 2s on the bottom. And if you look at here, these 3's cancel out and these 3's cancel out. So you end up with 3 to the third. Right? An easy way to do that though, so we don't have to rewrite it every single time, is just going, we're going to do the top one minus the bottom one. So 3 to the fifth minus 2. Right? 3 to the power of 5 minus the power of 2, and you get 3 to the third, like that. Okay, the next, which is, by the way, 27. 3 times 3 times 3. Anyway, the next one, x over x squared. So we're just going to go x7 minus 2, which is x to the fifth, right? Just like we put 7 x's up here, and then 2 x's down here, and then cancel out 2 of them. This next one, what happens when there's numbers? Nothing really. You just do the numbers separately. So 2 over 6, we can reduce that. 2 over 6, if we divide them both by 2, then we get 1 over 3. So that's going to be my answer. 1 over 3, now we got to do the variables. So we're just going to do each one separately. So we have x to the third over x. So that's going to be 3 minus 1, which is x squared on top. And then we're going to have y squared, y to the 6. So that is y2 minus 6, which is y to the negative 4. We'll talk about that in a second. So I guess something that looks like this. Now, if you remember from the thing we just talked about, you cannot have negative exponents. We don't want those in our final answer. So what we're going to do here is we're going to flip this y to the bottom. So I'm going to get x squared, 3y to the fourth. And that's the quotient power properties, right? So if they have the same base, you just divide them, top minus bottom. If you get a negative at the end, you do have to flip it to the bottom. And then the power of quotient property. So this one I actually used, didn't realize I haven't explained it already. If you have two things and they're also power, that could distribute to both of them. So it goes a to the k over b to the k. So I was going to do the first one here. That 3 goes to both of them. So I get 2 to the third, 5 to the third. 2 to the third is 8. 5 to the third is 125. Over here, right? That negative goes to either one. Goes to the top, goes to bottom, doesn't matter. I'll put it on, most people put it on top. So negative x to the fourth, y to the fourth. Remember, anytime you have an even power, it makes it positive because you're basically doing negative x times negative x times negative x times negative x. These two multiply to get you x squared, positive, because two negatives make a positive. These two get multiply to get you x squared, so you get x to the fourth. So anytime you have an even power, you get a positive number. So something like that. And then here, same concept, that the reason to go to every single one, even on the bottom. So it's negative 2 to the third, x squared to the third, y cubed, 3 to the third, and z to the third. Right? Notice I went to everything. It's not, I didn't just put it to the z, I didn't just put it to the 3, right? It goes to every single component here. So you get something like this. Now, this is an odd power, so it will stay negative. So negative 2 to the third is negative 8. X squared to the third, remember in this case, power to power, you multiply them. X to the 6, y to the third. 3 cubed is 3 times 3, which is 9, times 3, which is 27. And then z to the third. And that would be my answer to that one. And then last thing, rational exponents. So for this, like it shows here, if you have a to the 1 over n, the top is the power, the bottom is the root. So you could rewrite this as the square root of a to the power of 1, and then the root is right here. So that's what it means, right? So if you see like a fraction exponent, all it means is the bottom is the root, the square root of something, or the cube root of something. So if I see this first one here, 36, right? Remember the way it works? That's the power. And then this is the root. So if I'm going to rewrite it, power never changes. So 36 to the first, and the root is 2. Now remember, if you've never seen square root before, square root is like the opposite of a power. It's saying what times itself 2 times equals 36, right? So what times itself 2 times is equal to 36. And that number in this case is 6. 6 times 6 equals 36, right? So 6 squared equals 36 is the idea. So this answer is just 6. So same thing with the next one, right? That's the root. That's the one that changes. The power never moves. This is the power. So it's going to be 100. So I do a square root. Power of 1. This would be 2. So again, it's basically telling you, you're basically asking yourself, what squared equals 100 is the idea here. And the number squared equals 100? 10. So the answer to this guy is 10. So the next one, right, again, that's the root, and that's the power. So in this case, that's going to be 8 to the cubed root of 8, right? The power is 1, you don't need to write it. So again, this is asking you what to the third power equals 8, right? What times itself so 3 times equals 8, and that number will be 2. So that's my answer. This is 2. Okay, that's the lesson.